Now let's take a look at some of the different architectures for these big data systems. I'm going to start with the simplest of them, the key value pairs. Now these databases keep data in a simple schema-less tables that pair keys with their values. These make it difficult to run SQL-like queries. However, they remove the need to have schema predefined before storing data and still allow fast access for applications looking for specific values. Here's some examples on the left where you have keys and values, and on the right you have more of an advanced example that actually have a complex key that can be parsed by your application with the associated values. In this realm, we have databases such as the Azure Table Storage, Redis, MemcacheDB, HamsterDB, and DynamoDB. The next type of data storage system we're going to talk about is the column family stores. Now, here is similar to a key value pair. However, in this format, all of the attributes related to a single key are stored together. This is a kind of nested storage, which is really popular with many web applications and development methods today. So looking at our Facebook user example, rather than having separate rows for each key and value, we're actually going to store all of the attributes of that Facebook user into a single row here called data. You'll notice here that a family of columns live together for a specific key. And that's how it's similar to a key value pair, but is different in that it's a column family that lives together. Databases in this category are some very popular ones: HBase, Cassandra, and Amazon SimpleDB. Getting a little bit more complex and a lot more on the scalability and popularity, I'm going to talk about document stores. Now, document stores take data. In this case, this example, I'm storing a JSON document, which stands for JavaScript Object Notation, which is similar to XML, but with less definitions and less rigidity. And what it's going to happen in this example is when a document comes in, an original copy is going to be written to one of our data nodes, and then several other copies are going to be written to corresponding data nodes. This data can be chunked up into blocks and written independently, or it can be, if it fits within inside of a block, the entire data set can be written in triplicate here. Now this is where a lot of the really large systems come into play. Popular ones here are HDFS, that's the Hadoop Distributed File System, Elasticsearch, which is a search engine for documents or for large data sets, and CouchDB is another popular one. Because of the way the data is stored in these databases, it makes querying them for analytics extremely difficult. This is where many other add-on services and add-on tools live on top of document stores as a way to provide a SQL-like interface. We'll talk about some of that later when we get into actually accessing these data sources with Tableau. The last type of big data storage system I'm going to talk about is a graph database. Now, graph databases are based on graph theory. Graph databases employ nodes, properties, and edges. Nodes are very similar in nature to the objects that object-oriented programmers would be familiar with. Nodes represent entities such as people, businesses, accounts, or any other item you may want to keep track of. Properties are pertinent information that relate to nodes. And edges are the lines that connect the nodes or nodes to properties they represent, the relationship between. So let's walk through an example here. In this example, we have Ben, who is 32. Ben has a friend, Stella, that he's known since 2002. Ben is also in a group called Geeks and has been a member since 2000. Stella, succumbing to the persuasiveness of Ben, decided to join the group later in 2003. In this example, Ben, Stella, and Geeks are all nodes. The relationships they have that connect them are edges. And the properties are what make up the attributes of the node itself. Popular vendors in this space include Neo4j, Infogrid, and GraphBase. All of this may seem a bit overwhelming, but rest assured there are several platform vendors to your rescue, all for a price, of course. The biggest platform vendor out there is Cloudera. Cloudera offers a complete Hadoop system bundled into their CDH product. They also offer professional services and many other open source add-ons to Hadoop, one of which is very interesting called Impala, which lets users execute real-time queries against the Hadoop distributed file system. That's that document store database, which stores things very efficiently, but is very difficult when trying to extract data. The next platform to mention is Hortonworks. Now, many of the key people at Hortonworks are those that created the original Hadoop project dating back to its inception at Yahoo Labs. Hortonworks also bundles a lot of the different technologies you need to run Hadoop. However, they're more focused on an older build of Hadoop, and from what I've seen, haven't been pushing forward with many of the newer tools and versions of the underlying toolsets. Third, and possibly one of the most interesting, is InfoChimps. InfoChimps is a startup out of Austin offering a complete on-premise and cloud-based big data solution. Many new platform vendors like this are sprouting up daily as they race to capture your IT budget on your next big data project.